Yep.
Okay, well, we are going to go over section 3.3, which is writing functions today. So we're not going to be doing any graphing, which is exciting for those of you that hate graphing. And we're going to look at how to write functions from tables of values, okay? So if I'm given the values -1, or +1, -2, 2, -1, 3, 0, and 4, 1, I need to find my function rule, okay? So if I want to find my function rule, the easiest way to start is start by trying addition or subtraction. Okay, so I'm going to take my x value, which is 1. I need to do something to it to change it into my y value of -2. We're always taking our x's and trying to figure out how to get to our y's. So we would subtract, what? 3. Okay, so you always start with addition or subtraction. If that doesn't work, then we move on to multiplication division. Okay, so -3 or -3 is my function rule. So I'm going to repeat that all the way down. Okay, so then I start with my next value. My x value is 2. What is 2 minus 3? -1, which is what we wanted. Okay, so that's good. Then I do the same thing for my next x value of 3. 3 minus 3 is 0, which is what we wanted, so we're good. And then 4 minus 3 is 1, which is what we wanted, so we're good. So that's the rule, is -3. No, you can do it in your head. So then if we're going to write this as an equation, we start with our x value, right? We always started with our x value. Then we subtracted 3 from that x value, and that gave us our y value. So our function rule would be x minus 3 equals y. Okay, so let's do another one. So we're given the values 1, 3, 2, 6, 3, 9, 4, 12. We always start by trying addition or subtraction. So 1, something I'm doing to it to give me my y value of 3. So +2. So +2 is going to be my function rule that I'm going to try. It doesn't work. So if I plug in 2, 2 + 2 is 4, which is not what we wanted. So we know addition and subtraction doesn't work. So times 2. So times 2 times what? 3. So times 3. So 1 times 3 is 3. So times 3 becomes my rule. So if I plug in 2, 2 times 3 is 6, which is what we wanted. 3 times 3 is 9, which is what we wanted. And 4 times 3 is 12, which is what we wanted. So this one does work at times 3. Sometimes they won't work for either one, and that just means there's not a function rule. So if that happens, it's just not a function rule. So we're taking my x value and multiplying it by 3, and that gives me my y. You can write it like this, and this is okay if you write it like this, but what looks even better is 3x equals y, because we almost always have that number out front of our x. Okay, so you can write it either way, and either way is correct. I just like this one better because it looks prettier. Okay. All right. The second part of our assignment that we're going to go over today is independent and dependent variables. Okay, so your independent variable is always your input value. Independent goes into your equation, okay? And if you're given an equation, it's always going to be your x value. Your independent's always your x. Okay, your dependent variable is your output value, okay? It's what comes out of your equation. It's your solution. It's your y, okay? So independent is what goes in, and it's your x. Dependent is what comes out, and it's your y. Okay, so we're going to look at some word problems today, and we're going to identify our independent and dependent variables. So if I look at 2a, it says, in the winter, more electricity is used when the temperature goes down, and less is used when the temperature rises. So we are talking about temperature, and we're talking about electricity use. Okay, so temperature and electricity. And we need to figure out which one depends on the other. Okay, so perfect. Your electricity use is dependent on the temperature outside. If the temperature goes up, you'll turn your electricity down. If the temperature goes down, your heat's going to get turned up, right? So electricity depends on temperature, which tells us that our temperatures are independent. And our electricity is our dependent because it's the one that depends on the other, so dependent. That's it for that one. Okay, if we look at 2B, 2B says the cost of shipping a package is based on its weight. So we're talking about cost of a package, and we're talking about the weight of that package. Okay, so does cost depend on weight, or does weight depend on cost? Cost depends on your weight, right? The more heavy the package is, the more it costs. So your weight is your independent, because you can have a package that weighs anywhere from like 0 pounds to like 1,000,000 pounds, right? Depending on your package. But the cost of mailing it depends on how much it weighs. So if you want to spend less money, then you have a lighter package. Okay, that makes sense? Yes, no, maybe so. Do we want to do another one, or are we good? Another one. Okay. So 2C, the faster Ron walks, the quicker he gets home. So we're talking about his faster speed, his speed, so faster or speed. And we're talking about the time it takes him to get home, right? So does his speed depend on time, or does time depend on speed? So as more time passes, he'll get faster, or? Perfect. Time depends on the speed. So time is your, I did that backwards. I did that. That arrow goes backwards, sorry. Okay. Time depends on your speed. So your speed is independent. And your speed, or your time, is dependent. Okay? Most of the time, things like time, hours, etc., is your dependent. Okay? Okay, and the last thing we're going to look at is something called function notation. Okay? And function notation is represented by f parenthesis x parenthesis. Okay, where your x is in parentheses and you have an f, or sometimes you'll have like a g or an h. It doesn't really matter what letters out front, but there will be letters out front. Okay, and it's read f of x, or if this were like g, then it would be g of x, etc. And it's the same thing as your y. So if I'm giving you the equation y equals 2x plus 1, right, that's a simple enough equation. Function notation would be f of x equals 2x plus 1. It's just a different way of writing y. It doesn't change your equation at all. It's just a different way of writing y. Because when we use function notation, that helps us identify our input value. So we put our input value in parentheses. Okay? You're trying to figure out. Yep. So let's do some of those. So we're given a function f of x equals 5x, and it asks us to find x equals 6 and to find x equals 7.5. So I'm going to plug in this 6 everywhere that I see an x. So f of 6 equals 5 times 6. Okay, everywhere that I see an x, I put a 6. F of 6 is just like the same thing as saying y, so nothing changes on that. It just stays f of 6. And then 5 times 6 is 30. So I know that f of 6 is equal to 30. We don't do anything with the left side of the equation. It all stays the same. The only thing that changes is the right side.
Okay.
Perfect. So now we're going to do 7.5, so we'll do 7.5 in parentheses. So f of 7.5 equals 5 times 7.5. So then f of 7.5 equals 7.5 times 5 is 37.5. Okay, yep. I only know that because my 5th hour did that. And they did it on a calculator. What's up? Okay. So do we want to do this one or this one? Okay, so h of x. Remember I said it could be any letter, so in this case it's just h of x. Yep, so h of 12, 1/2 times 12 minus 3. Okay, so h of 12, remember nothing on the left changes, so h of 12 stays the same. What's 1/2 of 12? What's half of 12? 6. So 6 minus 3. So then h of 12 equals 3. Perfect. So the only thing that changes is the right side of the equation. Okay. Yep. Okay, so now we're going to plug in -8. So h of -8 equals 1/2 times -8 minus 3. So nothing over here changes, so h of -8 stays the same. What's half of -8? -4 minus 3. -7. -4 minus 3 is -7. Okay. So we do okay?
Yeah.
Okay. You guys are going to do 183, page 183, 1 through 23.